My name is Gal Weisman. I work for Consensus, and we've been working on a new web proposal called Realms Initialization Control. So I'll quickly go through it. It would be best to go through it by first talking about the problem. So it's important to understand that the web is evolving, and that's a great thing. One great aspect in which it's evolving, it's the supply chain driven development trend. So we're building applications on top of other people code more often. That's a really good thing. But at the same time, it becomes a bit more complicated in terms of security because we don't necessarily know, trust, or have the ability to maintain or update any code that potentially might be malicious, which is integrated into the origin of our application. In order to bridge that gap, I think it's really important that we find ways to secure further the origin of the application. And it's worth mentioning that that's a work in progress. There are a lot of JavaScript libraries and vendors that are trying to solve this by restricting or mitigating the power of native capabilities that the browser allows you to access, such as DOM APIs, storage APIs, network APIs, and so on. So one example of a library that might do would be this mitigate.js example. So this would be like a security vendor, and one thing that they might do is just completely eliminate the access to the fetch API of the main realm so that attacker wouldn't have access to it. But it's really easy for an attacker to bypass such security mechanism due to the same origin concern, which is what the proposal is going to be focusing about. So it's easy to bypass this protection because the attacker can easily just create a new same origin realm, such as an iframe, for example, and just grab a fresh new instance of the fetch API from within it, where the security mechanism does not apply. So what are we proposing? So we're proposing a new CSP directive that would accept a path to a first-party script that the browser would fetch and would make sure to execute that script within every new same origin realm that lives under the top, and would make sure to do so and run those scripts before any other script within the realm. So that would apply to top, iframes, pop-ups, picture-in-picture, all same origin realms potentially. And as you can see in the example, that would really help shipping security, the mitigate.js security file into all the realms within the application, so an attacker wouldn't be able to leverage them maliciously. The current state is that this proposal is being incubated within the YCG. The intent to prototype was filed, and we're waiting for further tag review as well as WebKit feedback, Mozilla feedback, and it was presented to the Web App Security Group at TPEC 24, and we would love some more help and feedback. Thank you.
Hello, Mentor Project, and Igalia has been participating in this effort. Now, let's take a look at the overall structure of Chrome iOS. This diagram shows the architecture of Chrome iOS. Traditionally, Chrome iOS has used WebKit as its rendering engine. For the new Chrome iOS version based on the Blink, the developer decided to retain the existing Chrome iOS structure to keep using the existing implementations. To support the integration with Blink, they introduced a new content module within the iOS web directories. This module is designed to interact directly with Blink. As I mentioned earlier, Igalia has been actively contributing to this project since it was made public by the communities. Now, I would like to share some of the key areas we've been working on. First, we focused on implementing various UI features such as the file, color choosers, and context menus. We integrated these elements seamlessly into the existing Chrome iOS UI to ensure a consistent user experience. In addition, we have contributed to multimedia features such as video screen capture, hardware encoding-decoding, and media recording. We also supported missing functionality, including geolocation, MIDI, and other features. Beyond the feature development, we've worked on setting up and improving various testing frameworks such as unit and breadth tests and web tests. We've also been maintaining the build for Chrome iOS on Blink to ensure that the build and tests are running continuously. Moreover, we enabled remote debugging support with DevTool for Chrome iOS. Now, I would like to show you a video of Chrome iOS running with the Blink engine. At first glance, it looks identical to the existing Chrome iOS browser because we only replaced the rendering engine while keeping the original UI intact. To demonstrate that Chromium is indeed using Blink, I will show you a CSS resize demo, a feature that is not yet supported by WebKit. As you can see in the video, the CSS resize functionality works well. However, if you try the same feature on Safari, which uses WebKit, it doesn't work. So far, we've taken a brief look at the current status of the project. However, there are still many functionalities that need to be supported in UI features and test cases. And also, we need to improve its stability and optimize the performance. That's it, and thank you for listening.
Hello everyone, I'm Priya. I'm a software engineer on Microsoft Edge team, and I'm here to talk about the implementation of System Accent Color for Chrome and Edge browser on Windows, and how it enhances the website and desktop experience. What is System Accent Color? Before diving into the browser feature, let's first explore what it is. They are customizable hues provided by the operating system to emphasize the key elements or user selection within the user interface. For example, Windows allows you to customize accent color by going into Settings, Personalization, Colors, and Accent Colors. Here, you will be able to select from predefined Windows accent color or any customizable color going here. Now let's take a look at how this feature works on Chrome and Edge browser. On Windows, the system accent color is channeled into browser color pipeline, which enables the web developer to access the user's accent color in two different ways. One as a CSS property called accent color for supporting form elements like radio button, checkbox, or progress bar to highlight the user selection. System accent color will be used as a default option if the accent color is not overridden for these elements in its style sheet. Now let's take a demo and see how it works with and without this feature enabled. I have a browser here which has this feature not enabled, and you can see here I'm using the style sheet with the accent color set to default or not provided at all. You will notice that the accent color on the platform is not the accent color that is used on the elements. Now moving to a browser which has this feature enabled, and you will notice that the color matches to the user color from the platform. Changing this also reflects on the forms. Another way web developer can access platform accent color is through system color keyword. In CSS, these are predefined keywords that corresponds to the color used in user's operating system. Currently, this feature is only enabled for installed web app for reducing the fingerprinting risk. Here is a demo where the browser with this feature enabled uses a paragraph with the background color set to accent color. You will notice that this accent color does not correspond to the platform's accent color. But the same website which is installed as a PWA can access the accent color for the platform. Changing the system accent color also reflects the change to the paragraph. With this feature enabled, website and PWAs are closer to seamless integration on Windows environment. This feature is currently behind a flag and expected to be enabled in few months. I appreciate your time and attention for this presentation. Please reach out to me for any questions.
Hi BlinkOn, I'm Kristen from the Web Install team, here to provide updates on how we're bringing installation to the web. Currently, you can install apps or websites through Add to Home Screen, Add to Dock, and PWA Install, but right now it's impossible to install web apps directly from websites. But with the Web Install API, this becomes possible. The API democratizes and decentralizes web application acquisition so that a website can install and distribute their own or other web apps. And we're doing this by having an extension to the navigator interface that takes the shape of a promise-based method that has the ability to install same and cross-domain websites. Since last year, we've added install URL as another parameter which should only include content required to install the app. There's also an additional signature which accepts no parameters and defaults to the current document manifest ID and install URL. And great news, we also recently received a satisfactory resolution with tag for same-origin. Same-origin web install finally puts full control in the hands of developers for how they encourage users to install their site for future use, and provides users a potentially consistent way of acquiring their web apps, regardless of their current user agent. As for cross-origin, it has the same install signature as same origin, except it does not accept the no parameters installation. Manifest ID and install URL are required. The workflow is also similar to same origin with the addition of a permission request. We are still committed to providing support for cross-origin scenarios, but we are processing feedback from TPAC and will be providing updates to TAG in the near future. Installing apps directly from web pages that reference them without losing your context and enabling users of app suites to install them all from one central place are just two examples of how cross-origin installation can be beneficial to both developers and users alike. And of course, we want to make it safe and protect users from spamming, which is why we're respecting the same origin policy for cross-origin. The feature is also gated behind user activation and installation permission. And we're also considering optional custom post-install UX so user agents can check in after install. As announced last year, we're continuing to work on the design of the Acquisition Info API, which pairs well with web install, as it allows web apps to understand how they were installed. You can continue to follow our progress and add feedback through the explainer linked at the bottom. And here are some other recent changes. We're no longer adding new manifest fields, install sources, and allow all install sources. We've also updated the explainer, so please take a look after this. And now for a demo of what we have so far. Note that this is a work in progress and we're still working through feedback from TPAC. Here we have our test app, PWA Store as a web app on the left and in the browser on the right. I'm going to install the Bubble web app where navigator.install will take in the manifest ID and install URL. So here I'll click on install, permission is requested, I'm going to allow, the install prompt shows, and I'm able to install successfully. We can now see in the app info here that permissions was updated and the same for in the browser. You can also see in settings content that the PWA store was added under allowed. Thank you for listening to our web install update. We'd love to hear from you.
Hi all, thanks for joining. This will be a very brief introduction to delegated compositing in Chromium. We've been doing a bunch of work in Viz to enable delegated compositing more broadly, especially on Windows. I'll go over the building blocks of delegated compositing, what it is, and why we want it. Special thank you to Vasily, Sunny, Raphael, Peter, Kyle, and many others. Let me start by setting the stage. Delegated compositing becomes relevant after Viz aggregates surfaces from the various renderers. The resulting aggregated frame has a list of render passes, and each render pass has a list of draw quads. A draw quad is a unit of drawing used by the Viz display compositor. It is normally a rectangle with some image content. Once we have the aggregated frame and draw quads, we can then decide how to compose them. Once we have a bunch of quads from the root render pass that make up a window, in the non-delegated compositing case, we ask Skia Renderer to do the window compositing inside Chromium. Skia Renderer will draw everything into its primary plane overlay, which is usually a swap chain that we hand off to the OS compositor at the end of the frame. Then, shortly after, the OS composes our primary plane and the other application windows to draw the desktop. Sometimes we can send extra buffers, such as those for videos, separately to the OS compositor. A hardware overlay lets us draw into a memory buffer inside of video hardware, which then gets composed on the screen by that hardware. It was originally an abstraction to help multiple applications draw to the same screen without stepping on each other. These days, the operating system abstracts this even further. In the past, applications drew directly to the OS primary plane and had to redraw their visible areas whenever window visibility changed. But today, applications draw into intermediate buffers and submit them to the OS separately. On Windows and Mac OS, the OS composes these buffers into its own primary plane, so we can't explicitly request a hardware overlay plane. But if the OS thinks that one of our buffers is a good candidate, it can assign it one. Videos tend to meet the requirements for being assigned a hardware plane since they are frequently updating, rectangular, and opaque. Letting a video draw in a hardware overlay plane ends up being very good for battery life. Delegated compositing takes this idea to the extreme. Instead of picking specific draw quads for overlay promotion, what if we say every draw quad is special? If we start again with our root render pass draw quads and promote everything, we can send it all to the OS compositor and end up with the same result. In this scenario, we've effectively replaced part of Skia Renderer with the OS provided quad composition. Note that we're still sending, for example, videos separately so the OS can still assign a hardware overlay plane if it makes sense. Here are some reasons why doing this is worth it. If we send all the quads to the OS, we can let it make the decision of what gets a hardware overlay plane, since it can usually make that decision better than we can. Since the OS composes its desktop all at once, it can aggregate damage across all application windows, for example, accounting for cross-application occlusion. On Mac OS, we do delegated compositing because it's the only way to get incremental updates when composing our window. On Windows, we previously had to disable OS translucency effects in Chromium due to power usage issues. Before delegated compositing, these effects would require extra alpha blending over the whole window, but with delegated compositing, we're able to do this extra blending only on the pixels that need it. Since we don't need to draw to an intermediate buffer, we can save a window-sized chunk of memory. As mentioned, macOS already does delegated compositing, but a lot of the work to enable it on Windows involves refactoring code to be reused across both platforms. This way, both platforms can benefit whenever we make improvements in Viz. Thank you all for watching. Bye.
Hello, my name is Song Cho, working on Microsoft Edge software engineer in the Edge team. Today, I'm going to introduce a new API that intended to address the problem in the audio output device selections. The problem we have is that audio output device for the application depends on OS settings default device, even though application overrides it by using API setPreferredSinkId on the same origin for the media element as well as audio context. However, it can do that for the cross-origin iframes audio output. As a solution for the problem, we introduce new API of setPreferredSinkId that sets the default audio output device for document and each iframe. It will affect all media elements and audio context that use the default audio sync ID. Here is a demo. Application provides a selection option for audio output device for the cross-origin iframe. It starts with a headphone and tried a couple more speakers for the better sound.
You should know this before you put that tape.
Right. More the fun experience to help keep camping more in sauce. Growth in addition to making it easier whenever to interact with data, save time in finding insights.
For example, using my new column, I can ask, how is revenue by category so far?
For this demo, application doesn't have to ask user to go to the OS setting or change the audio output device for the iframe. We are proposing and prototyping the API in the Chromium. We hope to have a developer trial available soon. Thank you.
Hello, my name is Gabriel, and I'm a software engineer on the Microsoft Edge browser. Today, I would like to go over the work that has been done to implement the media playback while not visible permission policy. But then, what is the media playback while not visible permission policy? The problem we are trying to resolve here is that embedded iframes can play media, and some of them might be resource heavy and take a considerable time to fully load. At the same time, the embedded iframe might need to momentarily pause media playback or hide the embedded iframes. And nowadays, the only option available is to destroy the embedded iframes and recreate them in a later time. The problem is that by doing that, we'll lose the state of the iframe, and we'll also need to go through the resource loading cycle again. This is where the media playback while not visible permission policy comes in. It should pause media playback for any iframes which are not being currently rendered on the screen. And this should apply whenever the iframes display CSS property is set to none, or when the iframe's visibility property is set to either hidden or collapse. Moreover, this permission policy should also interact with the HTML media elements, Web Audio API, and Web Speech API. Time for a quick demo. Let's quickly go over the work needed to make the permission policy work with the Web Audio API. Audio context can be paused by calling the suspend method. However, suspend can only be run if invoked by user code. And in our situation, we need the browser to have the autonomy to interrupt playback whenever it needs to. To help resolve this issue, we propose adding a new state called interrupted to the audio context state enum. This state would allow the browser to pause media playback for audio context whenever it feels like it needs to. This would also help aid other scenarios, like the audio session API and other scenarios where the application might need to have exclusive access to the audio hardware. What have been done so far? We have implemented the first working prototype for HTML media elements behind the feature flag on milestone 129. We have also started discussing with the Web Audio Working Group how to spec the interrupted state. Moreover, we are also engaging with the web community to gather feedback. Thank you for watching this presentation.
Hi, my name is Dan Clark from the Microsoft Edge team, and I'd like to talk about a Blink feature we've been working on called Reference Target. The problem that Reference Target is designed to address is related to the fact that Shadow DOM provides encapsulation, not just for styles, but also for aspects of the DOM like ID references. Often this encapsulation is what we want, but sometimes we need to create ID-based associations that cross Shadow DOM boundaries. An important example of this is when we have to express an ARIA relationship between elements spanning a shadow boundary. We do have a tentative way to establish ARIA references from inside a shadow root to elements outside of a shadow root by dynamically setting ARIA properties to actual elements instead of IDs, like on the last line of this code sample. Browser support for this isn't complete, but this is at least a path forward. But this only works for elements inside of the shadow that want to point out. It doesn't work for elements outside of the shadow root that need to reference something inside. For example, here we have a label outside a shadow that needs to reference an input element inside a shadow, but it can't. Referencing the shadow host fancy input doesn't create the right association in the accessibility tree, and trying to reference the inner input by its ID directly won't work because that ID reference isn't valid across the shadow. Reference Target is a proposed platform feature that will allow developers to make this kind of association. This is a property that's set on the shadow DOM that causes any ID references pointing to the shadow host to be redirected to the given ID inside the shadow. This example shows it working with a declarative shadow DOM to redirect the label's reference to fancy input to the element with the ID real input inside the shadow, which is the actual element that we want to apply the label to. The reference target can also be set imperatively when the shadow root is created with attached shadow and changed dynamically with a reference target property on the shadow root. This will work for most attributes that use ID references. This includes all these ARIA attributes except for ARIA owns, and includes non-accessibility related things like form associations, and attributes for newer features like popover target and anchor. Reference Target is currently available in Canary with Enable Experimental Web Platform features. If this is something you're interested in, please try it out and file CR bugs for implementation issues you find, or for spec feedback, please file issues in the YCG Web Components repo. To close, I want to thank Ben Howell from Microsoft, who put together the Reference Target proposal and implemented the prototype, and Alice Boxhall from Agalia, who did a lot of the early thinking about this problem that made Reference Target possible. Thanks.
Instead of using Chromium for browsing the web, let's explore how to use it for building applications. Chromium is open source, and its code base is organized in components which can be used for many different purposes. For example, Chromium is used for building browsers other than Chrome like Edge, Brave, Vivaldi, among others. You may also be familiarized with V8, the Chromium JavaScript engine that may be used to power scripting on server side, like Node.js and Dino. But in other known browser contexts, something quite powerful that you may not have heard of is to use Chromium to build applications. Instead, using Chromium for apps is giving a different perspective for the Chromium project and is being used for products serving millions of users today. An outstanding feature of the web is the write once, run everywhere concept. It means that developers usually want to use a single language and framework to build an application that will run on a variety of platforms. Sometimes, though, it's not possible to bring a native functionality to the web. For example, copying an image content from a web app into another web app was only possible recently. Sharing an image with a native client was also recently implemented. In terms of performance, getting parity with the native application is difficult too. So it's quite common to see applications designing deeper changes in the underlying platform to expose features that web technology APIs don't provide. The platform web view is not enough, or even that are not available in browsers. This is where the cross-platform application frameworks built using Chromium come into play. They provide ways to embed Chromium in applications and allow the use of the Chromium via higher-level API. Here is a curated list of these applications frameworks. Electron is a framework that has Chromium and Node.js combined into one runtime. And Electron is used for building well-known apps like Slack, VS Code, and others. A developer needs to write down in JavaScript to use it, and it's meant for desktop only. Once Electron version is updated, the app gets kind of it for free. Chromium Embedded Framework is used for building desktop clients like Spotify, Valve Steam, and Epic Games Launcher. There's a variety of language bindings for it, and just like Electron, it's good for in terms of maintainability. Chromium Content is the de facto Chromium API for web platform, and it is used for browser-like apps like Chrome itself, Vivaldi, Brave, and other full-fledged web browsers. It's essentially, who wants to use is essentially a Chromium fork. And just for completeness, we list here Web Layer, which is deprecated, but it's very interesting abstraction layer in Chromium. It's also meant for building full-fledged web browsers. So this presentation has reviewed the cross-platform application frameworks built using Chromium. There's no one-size-fits-all here, unfortunately. A developer wanting to build a cross-platform app will need to fully understand its requirements to only then embrace this solution. I hope you have learned a little bit with the presentation. Thank you.